All right, this is Gabby's vlog in Algebra 2 class. Here's Gabby. Okay, so if you are not in my session, teams in the back, /Isaac, /Alex. If you're not in my session, you are voices like off or silent or mini whispers. Okay, today we're starting with adding and subtracting. I want to start with adding and subtracting just like regular fractions. Like how we would do this. What has to be true in order to add these two fractions?
Common denominator.
Common denominator. So big deal. We have to have a common denominator. Common denom, right? How do we go about doing that?
Find least common multiple.
You can find the least common multiple, which would be what?
14.
14, right? How do I make 2 into 14?
Times 7.
Yeah.
Times 7. When I multiply by the bottom, I multiply on the top. The reason why I have to multiply on the top is because I'm technically, if I multiply by 7 over 7, I'm just multiplying by 1. 7 over 7 is 1. I'm just turning it into a different way. So for example, if I had 1/2, right? I have 1/2 of this, and I multiply times 7. I'm now splitting each of those sections. Wow, that was terrible. 1, 2, 3, 4, 5, 6. Each of those halves is turning into a 7. So now I have 7 out of 14, which is the same as 1/2. I have 1, 2, 3, 4, 5, 6, 7. Kind of funky. So this now is 7 over 14. I'm not changing, I'm not reducing it or condensing it or making it bigger or smaller. It's the same size. I'm calling it something different. Right? It's the same exact fraction. I'm making it more useful to me. Right? So then if I have sevenths here, what do I do to sevenths to make them 14?
Multiply by 2.
Multiply by 2 over 2. All right, multiply by 2 over 2. So now I have 14 and
6
6.
over. Yeah.
This is 13 over 28. 13 over 14.
14.
The whole goal was that we would have things that were the same size.
No.
All right, the same size. So now I have 13 over 14. Is that more or less than a whole?
Less.
Less than a whole. 1/14 less than a whole. Close to a whole, but not quite. All right, so we have to have a common denominator. Okay. So, any questions about this?
No.
Okay. When we are, I actually have a mini story for you. Okay, so get in, ready? Story time. So my mom, I love her dearly, is best friends with our next door neighbor. Okay. My next door neighbor's name is Phyllis. Does anyone know that name?
I like that name. Phyllis. Oh, look at Phyllis over there.
Like
Having
this.
fun. Hi, Phyllis.
Phyllis, like this.
Hey, Phyllis.
And it's a female name. That's a girl name. So
He's a guy.
she's like they're so funny. They've been best friends for now 20, how long did we move in that house? 25 years maybe?
Aww.
27, wait, how long? 25.
Long enough.
Long, right? They've been friends forever. And I love to, my dad loves to tell this story. He's always like, so one day when we moved in, we built our house. There was nothing there, right? And Phyllis moved into her house like shortly thereafter, and they're next door neighbors. But like the backyard is completely bare. All it is like some grass that came with the house, and then like literally in Colorado, like rocks. It's not even like gravel, it's like rocks around the outside, right? So my mom goes to Home Depot. She loves Home Depot. She said that if she wasn't a teacher, she would work at Home Depot. Really, it's her favorite store. So my mom goes to Home Depot and she's like, I want to buy a tree. She's from California. She loves trees. She wants to buy a tree. So she goes to she goes to Home Depot and she buys a tree and she brings it home and she plants it. She's like really excited about it. And then Phyllis comes over and Phyllis is like, oh my gosh, I love your tree, right? Like, I love it. I want one of my own. So what does Phyllis do?
Go buy
Buy
one.
tree.
She goes to Home Depot and she buys her own tree, right? But when she goes to Home Depot, she also brings home some flowers. So she now has now she has a tree and flowers. And my mom like peers over the backyard fence and is like, wait a second.
I like them flowers.
I like those flowers, right? So then she goes to my dad and she's like, honey, we have to buy some flowers. My dad's like, why? We just bought the tree. Like, do we have to buy the flowers? And my mom's like, yes, we have to buy them. Like, I want them, right? So she goes and she buys the flowers. My mom buys the flowers. But like also when she's at Home Depot, she's
buys
like,
something.
she's ridiculous. So she buys more things, right? So she bought, I think, like a wheelbarrow or something.
Oh,
So she buys a wheelbarrow. And then Phyllis, what does Phyllis do?
the wheelbarrow.
She's like, wait, I need a wheelbarrow. Instead of borrowing my mom's, she goes to Home Depot and buys her own. Right? So eventually like it pauses and they're all the same. But over the course of like 25 years, what do you think happened to their backyards?
They look the same.
Their backyards look exact, kind of a rose garden. Yeah, actually, they look like pretty much exactly the same. Because every time my mom gets something, Phyllis gets something. And every time Phyllis gets something, my mom gets something. And so their backyards look totally the same. It's like ridiculous. Their front yards, different, right? Their front yards are like, I don't know why. Their front yards, I guess, apparently don't matter. But their backyards look exactly the same. I don't know. That is my favorite story to talk about the fractions that we're going to deal with today. Because the backyards, the denominators, have to stay the same. So if one fraction has
okay, I
one
get it
thing, that other fraction
get it.
also needs that one thing.
Yeah.
And if the other fraction has something that this fraction doesn't have, we have to make them have the same fractions. Does that make sense?
Yeah.
Yes.
Okay, let's do it. So we're gonna use my mom and Phyllis. It's the best.
The backyard was the
Here we
denominator,
go.
right? You just got it. Exactly.
So 10 over 3x plus 15
Oh, is this a problem?
plus 1 over x plus 5. Okay?
Yep.
So, first step always
Always.
is factoring.
Oh.
We always want to see what we've got. We always want to see what we've got. Is there anything that can be factored here?
Yes.
What?
Good.
3x plus 5.
3x plus 5?
Yes.
Where's 3x plus 5?
3x per 15, he means.
Oh, 3x plus 15.
Okay, 3x plus 15. What can we factor here?
3.
3. Just like 3. Just write it.
Yeah.
On the
Take the
outside of
3
the
out of the
parentheses, and
middle.
then the inside you put x plus 5.
X plus 5. Okay, so I'm going to
sorry.
replace.
It sounds like-
I'm going to show you how I would. So on my paper, if I was like me, and I'm just like doing scratch work, I would just do this. And I would say like, okay, this is my new denominator.
Okay.
Oh, yeah.
Change it.
So that I'm not wasting like tons of time rewriting all the different things all the same time.
Oh, yeah, because that's like
Does that make sense?
Yes.
Like it just takes too long and I don't want to know.
Yeah.
So, okay, imagine this is my mom's yard.
Yeah.
This is my mom's yard. And my mom has a 3 and an x plus 5.
3.
But Phyllis only has an x plus 5. What does Phyllis want?
Go to Home Depot and
A
buy
3
it.
extra.
She's gonna go to Home Depot. She's gonna buy a 3, right? She's gonna buy a 3, right? So she's gonna
Wait.
buy a 3 here,
Okay.
but she also has to buy a 3
Upstairs.
Upstairs because
Upstairs.
in the front yard. I don't know. So either way, she has to buy a 3. So if we multiply by 3, we have to multiply by 3.
Yes.
So now we have 10 over 3 times x plus 5 plus, now we have 3 times 1.
3
3 over
x
3x plus
3
1.
x plus 5.
equal.
Now they have the same denominator, right? So the same denominator
I got it.
means the denominator stays the same.
Bless you.
Bless you.
You're welcome.
And then we can do 10 plus 3, which is
13.
13.
Nice. Figured it
It's
out.
gonna get harder.
I know. She always starts off with the super easy ones.
What's the question?
You would be like,
What's
oh,
that, right?
that's it. And then she would
I'm
get
gonna cry.
What did we mess up, Cody?
Oh. Okay, because I didn't see how you took out the 13 and 15.
Yeah. So we factored out that so we could see what was in common. And we saw they had an x plus 5 in common, but they didn't have the 3 in common. So we just multiplied the 3. Sweet. Okay, so then we just have to check, is there anything that can be simplified here?
No.
Does 13 go into 3 evenly?
No.
It can't be simplified. So this would be our
Your
independent class.
So
Nice.
there's
X is not allowed to be what?
oh there's
Negative 5.
Negative 5.
Wow. I totally forgot
Was
about
that your
that.
question, Gabby?
yes that was my question.
So we are.
And we always have to write the.
What are you
whatchamacallit?
doing? Why are you doing
What do you call them?
Excluded values.
Fluid values thingy.
I'm gonna write this down here.
You need to shade them lips.
shade.
Wait, but don't you already have it written down there?
Yeah, but I'm gonna erase this one
Ah, right.
so that I can write the color.
Makes sense. Makes sense.
Okay. So, but of course, over the years, my mom's yard and Phyllis's yard gets more complicated. So, the next one looks like something like this.
Come on, Phyllis.
Come on. Well, it's really my mom that was really complicated. But she never got the tree, man. It would have been all fine.
Wait, this is actually a true story?
Yes,
Yes.
it was.
Why would she
That's why
lie?
I told my classes 3 years ago.
Combined so well, like.
I know, right? I told my classes 3 years ago, and then my mom showed up on campus. She like came to visit the school because I was a new teacher. And
How's that tree?
What's she saying?
and people walked up to her and were like, "Are you Miss Matt's mom?" And then one kid was like, "Tell Phyllis we said hi."
Petty.
She'd be like, what the?
How you know Phyllis?
Okay, so
She busted the
oh,
new
let's go back. So, all right. So our first step was to factor, right?
Yeah.
What did we do after that?
We got the greatest. Oh no, I don't know. Wait,
So we
what?
factored this first. What did
Oh.
we do next?
You
We did it on the
multiply
same
3
side.
to get the same denominator.
Okay, so we made the denominators the same, right?
Oh, okay, yeah.
Made denominators the same,
And then you combined.
and then we combined. I realized we didn't finish our steps, so.
Can I?
Can you still see that vlog?
Yes.
Hello, vlog. Oh, you can't see step 3.
Hello, world.
Hello, world.
People of the internet.
Combined.
It's an erase on the bottom.
Okay.
Why are you?
He said hi, sisters.
Okay.
James Charles.
So first step was what?
eraser. It's down
Factor.
Factor. What do we need to factor here?
The bottom denominator of the first one.
Bottom denominator of the first one. So I'm gonna write under here. I'm using the X factor. I want us to start to be able to do the X factor in our head.
82.
That's what I was just about to say.
Multiply
Smart
to
one.
get this one.
8,
Add to get this one.
2, and the
So
2 will
8.
be negative.
And 2, and then figure out the negatives. So 1 has to be negative because it's a negative here. Right, so, and I want positive 6. Do I want 8 minus 2 or 2 minus 8?
8 minus 2.
8 minus 2. So then this has to be positive. If you're still
Whoa.
on the X factor, you can. Yes.
I like just jumped up a step. I'm like,
Oh yeah. Okay,
so, huh?
not yet, not yet. So this is gone now.
hmm
That is gone. That's our new denominator.
Yeah.
David, thoughts?
My thought is, okay, so are we gonna have to add the x plus 8 in parentheses to the other denominator or
So
no?
it's gonna be one on top.
Not add it, but multiply
Multiply
it.
them.
Yeah. So like if this is my mom's yard, Phyllis already has an x plus 2 or an x minus 2, but Phyllis
X
wants
plus
an
8.
x plus 8.
Yeah.
So I have to give. Phyllis goes to Home Depot and gets an x plus 8,
Oh, and then you do the same thing
and
for the
also
top.
on the top.
Well,
I keep
So
breaking
this
my
one.
pencil.
I can
See
hear
if I can
it.
use color here. X minus 2 was already a part of both backyards. They already both had a tree or whatever. But then my mom went and got flowers. And now Phyllis wants those
is
flowers.
it always gonna be one that's the same?
They might not always have the same, but probably. For the sake of our problems.
Okay.
Probably.
Okay.
Okay,
What would
so
we do if they don't? We would just have to find these common multiple. Like if it was like in parentheses, what would we do?
So like when it was 2 and 7, they don't have anything in common, right? So we just did 7 on the one and 2 on the other.
Yeah.
So we just multiplied times each other.
Oh,
What did you cancel?
This, I turned the x squared plus 6x minus 16 into its factored form.
No, what did you cancel?
I haven't canceled anything. This was the original problem.
Sorry, I just had to like look at yours.
This is the original problem. And now Phyllis needs an x plus 8, so I'm putting an x plus 8 here. But what I do at the bottom, I also have to do the top. Okay. So now, my common denominator
Yeah.
is x plus 8 times x minus 2,
And the top.
right? The top is still this.
Do we distribute? Oh, look.
3x plus 2, 26.
What's so
Be
late?
careful, there's a minus here.
Because I understand it, bro.
This minus is applying to the whole thing here. So it's like multiplying -2 times these things.
Why don't you just move? Why didn't you just distribute the 2?
Well, I can do that. I'm going to leave the negative here though, because
Okay.
the negative applies to everything.
Okay.
So this would be 2 times x,
Negative
2x,
2x.
and then 2x times 8 would be plus 16.
You don't even have to distribute. You could.
That's
I
lit.
don't have to distribute.
Like I was thinking, like you don't even have to simplify that even more. You could just do 3x minus 2x.
3x minus 2x, and then
then
26 minus 16.
16.
Yes, as long as you remember that this negative applies to both of these things.
Oh, okay.
So you would add combine like terms, yes. So 3x
That's what
minus
you said.
2x would be x.
I didn't understand you.
26 minus 16 would be
X plus 10.
10. X plus 10. And then our denominator still has x plus 8
Mm-hmm.
and x minus 2.
Yep. And the excluded values are what?
And x never or cannot equal is undefined at where?
2 and negative 8.
2 and negative 8. Good job, Tazzy.
Awesome.
Thank you for that reminder, Rohan. I heard you.
Whoa.
Can I'm gonna push our thinking just a second. Hypothetically, this is a
Okay.
hypothetical. I see some people putting their pencils down. Good idea. Hypothetically, if this had been a x plus 8, what could we have done?
Cancel it.
Cancel
this.
and then just
Cancel this.
have it be 1 over x.
So we can cancel it.
Does
So
that
you
actually
can
happen?
cancel at the end. That does actually happen
So
sometimes.
we only cancel at the end, not during the process.
Do not cancel during the process, because like if we cancel right
yeah.
here, we wouldn't be able to add them together anymore.
But what if there was like an X plus 8 right there on top? And
X plus 8 right
yeah.
there. No, you can't cancel because it's being subtracted with this.
Oh.
Remember, we can only cancel if things are being multiplied.
Because
Okay.
that is just a simplified version of that. So that's why you don't do it until you get the answer of the
Yes.
simplification.
So our goal, we make this actually more complicated so we can put it into one fraction. And then once we have one fraction, we can simplify. Right? So really maybe our last step. Maybe there's a 4th step, simplify.
Wait, how do you simplify?
We can simplify this, Crystal. We were talking about a hypothetical situation in which this was 8, x plus 8. We could cancel
Watching
this
cards
and
over
that, and have 1 over. Okay. Are you fine? Jeez.
I know. Are you okay?
All right. This is my last example before I give you a practice. Come on, y'all.
Awesome.
Here we go.
I know with the giggles.
All right. X plus 3 over x squared plus x minus 2 plus 2 over
It's over.
x squared minus 1.
Sorry.
Oh. Oh.
Ugh.
I know.
Nice.
No, it's not.
Not nice. Not bad.
Not nice, my bad. Oh, snap, it's a musical throwdown.
Okay. What can and can't I simplify?
The bottom left.
The bottoms.
You can.
Both of them.
The bottoms can or cannot?
Can.
Can.
Okay, this one's an X factor.
Bless you.
Bless you. This one's an X factor. Can be simplified. What about the top?
No.
Numerator? No. That's just x plus 3. Can 2 be simplified?
Yeah.
Yeah. Wait, no.
I'm sorry. Say it again.
Can 2 be simplified?
No, it cannot. No, I'm sorry.
Okay.
Don't
And
mess
then
with my brain.
x squared minus 1. Can it be simplified?
Yeah.
Hi, Eddie.
Hello.
Hi, Annie.
No, I said I don't.
¿Qué pasó?
Look.
Okay. X factor this. I need 2 numbers that multiply to get negative 2 and add to get 1.
Yeah.
2.
Negative one.
Positive.
2
Yeah.
and 1. And 2 is a positive?
Yep.
Yep.
Nice.
Yeah.
And then this is what?
X plus what? X minus 1.
How do you know?
Because
they're
it's a difference of squares.
doubles, different
Difference of
squares.
Matt,
squares.
bro.
X plus 1, x minus 1.
Ah, it's deep. It's deep.
Okay.
Oh, this is gonna be hard, miss.
Why
All right, zone in for me. Zone in.
Yeah.
Not our, we're off task and we're on video.
Oh. Sure.
So this is my mom. My mom has an x plus 2 and an x minus 1. This is Phyllis. Phyllis has an x plus 1 and an x minus 1. Do my mom and Phyllis have anything in common?
Yes.
X minus 1.
The x minus 1. So they both have here x minus 1 already,
Yeah.
right? Why is my mom jealous of Phyllis?
Because she's got actually Phyllis is jealous of your mom because your mom
They're
has
both
X
jealous
plus-
of each other.
Oh,
They're both jealous of each other, right?
smart.
Yes.
My mom has an x plus 2 that Phyllis does not have. So Phyllis is gonna go to Home Depot and she's gonna get an x plus 2.
Oh, I get it now.
Oh. Right? But now Phyllis has 3 things. Right? Phyllis has the same things as my mom. Phyllis is good, but now my mom is jealous. Why is my mom jealous?
Because
She don't have
Wait,
an X
no,
plus
we
1.
didn't-
She doesn't
Oh.
have an x plus 1.
That's true.
So now I'm gonna multiply times x plus 1
Ooh! They just had to get that.
I know, man. That's
times
a
x
lot
plus
of
1.
Okay.
Do we have to square that? Box it?
Box it. Yes.
Wait, box
figured.
it. Oh,
Wait, why don't?
Things times 2.
Never mind.
darn.
I know.
Interesting. Alright.
So
Good though.
I'm gonna have one long fraction. You
Yep.
want to take a second to try?
yeah.
Okay,
Yeah.
take a second. We're boxing this. Some people told us. What are we doing here?
That's a lot actually.
It is a lot. I know my denominator is gonna have 3 parts because it's the same 3. So now everybody's backyard is the same.
Oh wait, no, that's wrong. Okay, there we go. I fixed it. No, you're not. No, you're not. No, you're not. No, you're not. No, you're not.
This is this, right?
Oh, right, yeah. I'm sorry.
Apologize.
No, right?
No.
That's a dislike. Thumbs down.
Yeah.
Say again? How to add them? So I'm gonna, this is one big fraction that has the same denominators, right? So I'm adding this numerator here and this here. This one's pretty simple, yeah? This is 2x plus,
That's what like David Jones does.
well, we are gonna combine them. We're gonna add, did you get the box? What is this?
X squared plus 4x plus
Or x plus
3.
3. Okay, so I have, this is the first, this is like my mom's yard,
And then
and this is
Why he
Phyllis's
doesn't
yard, right? But now I can combine like terms in the numerator. So when I combine like terms in the numerator, I'm gonna have x squared, 4x and 2x makes 6x, 3 and 4 make 7, all over x plus 1, x plus 2, x minus 1.
Oh, I rushed it.
Then I'm gonna ask myself, can I factor this?
I mean, I rushed it.
Is there anything that multiplies to get 7, adds to get 6?
No.
6 and 1.
Yes. No. No, 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 no. Nope.
No.
Nope.
7 and 1. Yeah,
Nope.
you need a negative here, right?
But
Yeah.
it's
This
not.
has to be 7 and 1, so that has to be 8. So
Yeah.
nothing.
Yeah.
So x does not equal.
Ew. So then, wait, question.
Is it ill?
Ew.
I know.
Yes, David.
So the top is like that, but then we can do an Xbox where you have to do that?
Yeah.
That is so nasty.
I know. Can you do quadratic formula?
David. No, he did not do.
There's not a reason to. Because they're asking us to simplify, not to solve. Solve would be like x equals a number. We're just simplifying. We're trying to take something that is 2 parts and make it 1 part. Yes. If you could, yes.
No.
You jerk.
If you could. Bye. Thanks, team.